This is Module 3 of the OpenTelemetry eLearning. In this module, we will introduce instrumentation. Objective of this module is to understand what is instrumentation, know for you what is the difference between auto-instrumentation and manual instrumentation. We will see the list of languages that are supported, and we will introduce some sample of code in order to demystify the subject and show by example. You will also have 2 labs in order to practice the instrumentation of Node.js application. But first, let's start with what is instrumentation exactly. Instrumentation is the process of adding observability code to your application. This observability code is used in order to add specific attributes, add information, or add log events into your code that will be visible in your traces or that will be visible as metrics to your application. There are 2 types of instrumentation. The automatic instrumentation dynamically injects bytecode to capture all technical events and technical attributes from your application. It is mostly used to capture telemetry data in your application, such as all calls to different functions, HTTP calls, outbound calls, database calls using JDBC, for example. Manual instrumentation, on the contrary, relies on the developer to import the OpenTelemetry library and add code in order to capture the telemetry data. Be aware that automatic and manual instrumentation are complementary, meaning that in most of our projects, we will recommend you to start with automatic instrumentation if it is available and complete it with manual instrumentation to add your own attributes or your own log events. This is a list of languages that are supported by OpenTelemetry in order to do instrumentation. The ones that are in green are supported with auto-instrumentation, meaning that if possible, you will start with just adding the OpenTelemetry library and wait for auto-instrumentation to work and provide you at least already technical attributes, exceptions, messages, and calls to the different libraries in your code automatically. The other one needs manual instrumentation, meaning that they will need you to import the OpenTelemetry library and add modification to your code. In order to do manual instrumentation, you will have to do this step-by-step approach. First, you will configure a tracer in order to know exactly how you want to instrument your code and import the dependencies from OpenTelemetry libraries. Then, you can create your own span. Based on an existing context, you can use this span to add attributes, to add log events, or to add operations to your traces. And finally, you will propagate the context so that it can be used with the other functions. This is an example on how you can create a tracer with Node.js code. You can see first that you should declare dependencies, meaning the OpenTelemetry libraries that you want to use. Then you will declare where do you want to send your traces and metrics. Typically here we send it to a Lightstep satellite, but most of the time you will send it to an OpenTelemetry collector. Third, you can declare the plugins that you will use. It could be auto-instrumentation or it could be any plugin linked to the technologies and protocol that you use in your code. Let's zoom to the destination of your telemetry data. As you can see here, we show you an example on how to send your data directly to Lightstep by providing a URL to your satellite and providing in your header the token that you want to use to connect to the platform. If you want to send your telemetry data to an OpenTelemetry collector, it is very similar to what you have done for the Lightstep satellite, except that you don't need to provide any token to connect to this collector, but just the URL. In order to create a span, we will use the OpenTelemetry library in order to get the existing tracer. Then we will just use the start span function. Once you have created a span, you can add attribute to it or log events using the set attribute or add event operations. Finally, be aware that for each span that you create, you should also end it, that's with the end function, and you can create for sure child span to this span by using the start span function again. This is a summary of all the span methods that are available. You can start a span with a start span. It will use the existing context in order to attach the span to a parent one. You can use the context with in order to capture the existing context. So if you don't want to start a span but reuse the existing one in order to add attributes or log event to this one, you should just use this function context with. You can get the existing span also based on this context, and you can add events or set different attributes with the add event and set attributes methods. At the end, don't forget to always end any span that you have created. In order for OpenTelemetry to work correctly, you should propagate the context, meaning that you should send the context to the different methods that are used either in your code or with the call of different APIs. For this, we can use, for example, the W3C trace context if you're using the HTTP protocol, or you can use any manual propagation that is available with your code libraries. And this is detailed in the OpenTelemetry standard documentation for any different language. Putting it all together, this is an example of instrumentation of a Node.js application, where you declare the libraries of OpenTelemetry first, then you create your tracer. You use this tracer to create different spans and add attributes and log events to it. And you don't forget to end the span that you have created at the end. This example of code that has been provided for Node.js is very similar to any kind of code that you can use and any kind of methods that you can use with OpenTelemetry with the different languages that are supported. Be sure to always refer to the appropriate documentation for your code in order to get examples and know exactly how it works. At the end, if you want to export the telemetry data that you collect in your code, it is recommended to use a collector and use this collector as a proxy to send it to any different targets or backends that you want to use. Many different instrumentation examples are provided in the official site of OpenTelemetry and also in the Lightstep site. The Node.js OpenTelemetry API documentation is provided in GitHub, and you can find the same for any different languages. Be sure also to refer to the plugins that are available on the core distribution of OpenTelemetry or on the contributor distribution if you want to get the contribution from the different vendors. Now you can go to the different labs in order to better understand and practice instrumentation of your code.